tall wall on the north side, and that protects them a lot from the wind, the north side and the sides of the roll-off, because of course in Edmonton there's not a hell of a lot north that you want to look that isn't straight up because of being that far north. But if you thought about having one side taller than the other, that try and put the tall side on the north where you might get some prevailing wind.
Yeah, good idea. There's another thing too. I've been investigating these various size meshes that you can get that actually slow down and even stop wind depending on the size of the mesh and the pattern that you put down.
Yeah.
So you could actually open up your roof and extend these things in the direction that the wind's coming from.
Yeah.
But you've got to do it just right. So I'm going to be fooling around with that too.
So Gary, you said it was in central Saanich though, right?
That's right, yeah.
Because where I'm at, we don't have any wind. Like if it's clear, it's about 99% probability that there won't be a touch of wind.
That would be lovely. That would be lovely.
I don't know. I'm up near sort of the charts down on that end. I don't know where you're going to be. But.
Yeah. Basically, I'm just at the end of Mount Newton Valley, just north of Saanich. So it's a great spot. Open fields on a friend's farm. Great views all around. So I'm very excited about that. So it should be fun. I get to build another observatory, hopefully my last, but it should be a lot of fun to do it.
How about the trees? How's your horizon?
Good, they're good. But it turns out, and this is an interesting bit of a fallacy. If you're an imager, you don't image anything below 30 degrees anyhow. So although it's nice to see down to the horizon, it's just simply a nice aesthetic, which is fabulous. But you don't use it in imaging at all. And in visual, you do use it. So I'm going to be sticking a door in the south side of the observatory so that I can get the visual scope down to the horizon facing in that direction.
Great. Well, welcome everyone. It's coming up to 25-2, not quite yet. See, we've got a good crew here so far. 30 people checked in. So happy New Year to everybody. And glad to hear you're safely almost back with us, Gary. So that's good news. So on the agenda tonight, I have Randy wanted to say some things, and then we've got a couple of things from Dave Robinson. Does anybody else have anything for us this evening?
Yes, I have something.
Okay, Alex?
You're interested in pictures of construction at UVic.
Right.
And pictures of the sun.
Okay, thank you. Anybody else?
Chris Gainor, are you going to keep keeping us up to date?
Yes. Okay.
Good.
On the list. And from earlier on there's been some people up on the hill. So is there an update on what may be happening up there or not?
I could show a picture.
Sure, why don't we do that? So what's up with the VCO? Sounds good. Great. Well, again, thank you for joining us, everyone, this evening. So Randy, are you
very good.
Ready to roll?
I am. So do you have my picture?
We
do. See my pictures?
Yes, we do.
Yes, there.
So what we have here is from last night, pictures from basically 6 p.m., 7, and 8. Very different technologies, and that's just fine. But I want you to see about how you can actually see the sun moving across the moonscape over these 2 hours. I just love this. So this is Blanchinus, this crater here, and it shows up just after the quarter moon. So quarter moon was at 10 in the morning, and just a bit after, then you've got this funny condition where you have Lacaille, Purdock, Regimontanus, and Blanchinus all having their edges. And so you get what my family is calling the lunar scissors. But you can see that you don't get this whole branch here in Mike's picture at 6 o'clock. By the time I was sketching, then it really does make a very nice set of scissors. And by the time that Bill took his picture, and I'm sure the optics were nice, but this was just done with an iPad through the telescope. So don't feel bad for Bill that he was looking at a fuzzy picture. I'm sure it looked great with his eye, but you can see now how Blanchina is actually a proper crater by the time 2000 or 8 o'clock pulled around. So I think this is just a lovely case where, with three completely different technologies, but you can see the sun moving its way across. There are other things about this picture that I found quite delightful, like getting these little rims of craters way off the terminator. That always delights me, but I really like this. There's this thing here, at least in, what do you call it? Ruckles. Oh, you can't even see the picture. Ruckles Atlas of the Moon. It's not named. It's just an area between craters, but I think it's pretty clear in all three of our pictures that that is a crater. Makes you wonder, how, sometimes it's very easy to say what is a crater, but sometimes it is, it can be a bit tricky. But yeah, this one doesn't get a name in Ruckles Atlas. Anyway, I was just delighted to well, first of all, to have a clear sky for an evening, my goodness. And then I hope lots of people got to enjoy it yesterday. But that's not what I'm going to talk about. What I'm going to talk about is Don't Look Up.
Mhm.
So this is the hot movie on Netflix right now. It's got all of the big stars, and I have to say, it's a must-watch movie. It is very depressing, but it's also very funny. And I'm not going to talk a lot about it, but I am going to talk about one of the people who is not on the front credits, but really is, in a way, the star of the show. And it's Amy Mainzer, who was the science advisor for the show. And it is full of very, very good science. Also, very good, what it's like being the only female scientist in a room, and the relationship between grad student and supervisor. And she was involved for 2 years on this project, and she talked with each of the stars and tried to tell them what it's like being a scientist. And the other thing I want to point out is she is the principal investigator for NEOWISE. And remember, WISE, I don't remember what the acronym is, but the I is for infrared. It was a very good infrared telescope, but when it lost its coolant, they tasked it and called the mission after that NEOWISE. NEO because it's new, but also because it's near Earth objects. It's the big thing. Like you remember Comet NEOWISE last year. Anyway, she is the principal investigator for NEOWISE. And among the things is she provided some NEOWISE photos for Jennifer Lawrence to put together, superimpose in this picture, and to say, oh boy, that's a big comet coming towards us. So that's kind of the very setup of the show. They show her sitting in the control room for the Subaru telescope. It's very pretty, but these are actually pictures taken from NEOWISE. And then her supervisor, played by Leonardo DiCaprio, comes out and they have this big team meeting, and he decides that they should figure out where this comet is heading on a whiteboard. And I kind of thought about, like, I wouldn't be able to do that. I don't know about Leonardo DiCaprio. Anyway, I actually found the script online. Somebody has typed up the whole script of the movie and put it online, which is pretty fast. It's only been out. It hasn't been out for a month yet. Anyway, so somebody in the team says, how do you find the comet's velocity in orbit? And so DiCaprio says, what a great question. I haven't done orbital dynamics since grad school. The question is, what would Carl Sagan do? And then he brings out his little toy figurine of Carl Sagan. And I think Carl Sagan would not work out orbits from first principles, but there you go. Anyway, just, a minute later, he's working away on his white screen, and the grad student is reading out numbers, and he's doing his things, and he's writing out the numbers in units of time, what its distance from the Earth is, which he calls the ephemeris, and finally writes 0.00. His hand is frozen with the marker in front of the board, and then he quickly erases it. Anyway, and then hilarity ensues. Okay, so that's kind of the setup. And just to give a similar but different case, let's go back to 1801. So Kepler's laws and Newton's dynamics are well understood, but there's also this thing called Bode's law, or the Bode-Titius law, which is saying that there's this really simple rule about how far each planet is from the sun, except it's missing one at 2.8 astronomical units. So between Mars and Jupiter. And so in the end of the 1700s, there was this whole program to see whether there was a planet between Mars and Jupiter. And the best astronomers of the day kind of split up the zodiac and each took a piece of the ecliptic. And Giuseppe Piazzi lucked in to have Taurus. And the idea of doing this without a camera blows me away. But he saw that in his field that he was in charge of, there was this one little dot that was moving, and he followed it for 21 days. So this is so here's Taurus. Okay, there's Orion pointing at Arcturus, so that's how you know this is Taurus. So he saw Ceres moving along this little trajectory, and then it went behind the sun. It was lost. And so the question was, if it's a planet, then we should see it coming out the other side. And so all the clever astronomers of the day tried to figure out where it was going. It's not easy because you can see it. It's actually just coming out of retrograde at the time. So you can't draw a straight line from that. And they were making predictions all over the place. And then 24-year-old Gauss, 24-year-old, never done any astronomy. He's only, he's a mathematician. But he works out the orbit of the trajectory of Ceres to within minutes of where it's going to be found. And two people found it. Von Zach and Olbers found it respectively on the last day of 1801 and the first day of 1802, so a year later. And in the process, he also invented the Gaussian distribution that we all use in statistics every day, and least squares fitting. And I mean, the guy just revolutionized so many aspects. It just blows me away. But it was quite something to realize that he was only 24 years old when he did this stuff. So what did he do? Well, it's tricky. You've got, first of all, the hypothesis that what they were looking at is an object, B, on an ellipse with the sun as one focus. Okay, so that's the model. And you've got the Earth going around on another ellipse around the sun. And so you make these measurements, rho, but you have to figure out what R is. All you've got is the direction towards this. You don't know any of the lengths. It's pretty wild. So you can see here's the Earth moving along, pointing up. So all they get is the right accession and the declination, and across 3 degrees of arc. That's all they had. You know, Kepler, when he was looking at the orbits of the planets, he was looking at full ellipses. But before Ceres went behind the sun, there was 3 degrees of arc. And so just based on first principles, like Leonardo DiCaprio, he knew that it was on an ellipse with the sun as its focus, and that it would sweep out in any unit of time the same area. Okay, Kepler's third law. And
Diane and I are reading a history that involves Carl Gauss, and actually it's funny because the night before last we were just reading about his deriving this, and in the novel it says it came to him as in a flash on his wedding night to his second wife, and he had to get up from the bed and go over and write it down in his notebook before he could go back to bed and finish off consummating the marriage.
That's great. That adds a whole other dimension to this. He was famous for not just cranking out computations. It was very geometric. It was very intuitive in a way that nobody else was able to do at the time. If I understand correctly, he started with an approximation that it was exactly halfway between Mars and Jupiter. He only used 3 dates: the first observation, the middle observation, and the last one. And he did some intelligent guesses to work out just from the middle, so from P2, it restricted the range of possibilities. And then he pulled out the trajectory using P1 and P3. And then to confirm it, he used the second day and the penultimate day, the 20th day of observation, to check his calculations. It apparently took him 100 hours of calculation. Again, not the sort of thing you just do from first principles on a whiteboard, but he got it, and he got it right. And this is not how he would have done it, but this is just to show you one paper that goes through it. There's a lot of math going on. And don't ask me to explain this, but it's he didn't even have our vector notation to do this. I'm really blown away. Anyway, later in the movie, this is not a spoiler. It's like pretty obvious this is going to happen. So professor and student end up in the president's office telling her what's going on. And he goes on, you know, average astrometric uncertainty of 0.04 arc seconds. That's pretty good. You know, that certainly is major telescope sort of precision. And then they finally get to say to the president, comet is headed directly towards Earth. And then Kate says, according to NASA's computers, this object will hit the Pacific Ocean 62 miles due west off the coast of Chile. And this is in 6 months and 14 days. When I watched the movie, I didn't catch that they said, according to NASA's computers. I thought they did all that on the whiteboard, and that one really bugged me. But when I saw the script, that according to NASA's computers, so they had extra measurements of it by the time they went to see the president. But I did see that NASA has this thing called Horizons system, which does, what Gauss did today is called the initial orbit determination, IOD. And that's the sort of thing that you do when you assume that it's an ellipse around the sun. But in fact, there's all these different bodies that are pulling on any object that's in orbit. And to do something accurate, like saying 62 miles off the coast of Chile on such and such a day, you need to do it with this program called Horizons. But it's available, and apparently this is how they aim the spaceship to intersect Pluto, or how they do those incredible manipulations to get Cassini to go around and take a look at all the moons around Saturn. So it is, they have this publicly available service now to work out these very detailed numerical calculations of orbits, but not on a whiteboard. That's my punchline. And with that, I say thank you.
Any questions or comments?
Yeah. So Randy, so I thought that was not feasible to calculate the impact with such precision, knowing that they haven't been able to guess when a satellite's going to fall to Earth. But so that Horizons system would be able to calculate with a high degree of certainty the precise location and time of an impact.
Okay, does anybody here know this? I mean, all I can say is that science advisor Amy Mainzer worked hard to get everything very realistic. She wanted it to be 4 years in the future, but for artistic reasons, they decided to put it 6 years and 14 days. So how much of it is that it made a good story, and how much of it is accurate? I don't know how to answer that, but it's more often than not the details in this movie are correct.
There's a major uncertainty with the satellites deorbiting, because the atmosphere accelerates their deorbit, and depending on the atmospheric conditions and how they enter the atmosphere will have a big effect on the landing point. But something that's
this is a 9 kilometer boloid. I don't think the atmosphere is going to be visible to it.
No, between the speed and the angle of entry, it would probably just be effectively a vacuum.
Yeah, I think, and there was discussion about what size. She didn't want to make it so big that there was nothing you could do about it. She wanted it to be just big enough that it would be at least a dinosaur extinction sort of event, but not so big that there's no point even trying to deflect it.
So just a different view of this. They're actually using a science that's capable of very precise calculations, thanks to Gauss, of movements of astronomical objects. And they're trying to build a metaphor for global warming, and say that the science of climate change is the same as the science of astronomy. So there is a political slant to this whole movie. So, I mean, the point they're trying to make is scientists can calculate things to very high degrees.
Yeah.
So I'm just saying there's a political slant to the whole movie.
Oh, the movie is very, very political.
This is similar to Larry Niven and Jerry Pournelle novel from the mid-'80s called Lucifer's Hammer, which involved a comet that was didn't strike Earth but missed by a small enough margin that the small pieces that were calving off peppered the Earth with multiple impacts, and how the society and the people tried to survive afterwards. So it's interesting takes all the way around.
Thank you. Peter Jackie, you had your hand up at one point, but you've lowered it. Did you still want to say something?
Hi, Chris. Hi, everyone. I posted in the chat lines there in the text a link to a review by a friend of mine named Mark Boslow, who is in turn friends with Amy Meinzer. And so he's got a couple of comments about this, but I just wanted to say for everybody to hear that I recommend you don't read the review until after you've watched the movie. It does, I mean, more so than our conversation in the last few minutes, it does kind of give some spoilers away. But it's a pretty useful thing because Mark is a top scientist in the field of asteroid impacts. And so, you know, what he says kind of means something. He's not one of the calculator guys. I know we were just talking about the calculations and how well they do it, and Horizon's website. Was there a link posted to the Horizon's web? Because I've got that link available somewhere too if someone wants it. They call the website the Solar System Dynamics, ssd.jpl.nasa.gov is the starting point. And you can go there and look up any asteroid that's been designated or comet. You can do the planets as well. And somewhere on that website as well is the links to the Horizons functions that Randy was talking about. And so that, anyway, I watched the movie with some scientifically knowledgeable folks, and you know, there was a bit of disagreement about whether or not it's you know, a positive or a negative thing for depicting scientists, but I enjoyed it a lot. I think that the sense of irony is really quite remarkable. US Hollywood doesn't usually do such a good job of irony, and as Randy mentioned, there's a lot of humor involved in that. Anyway, just a couple of thoughts there. I just wanted to point out the business about the link being there for you. And hi, Lori, I just got your message there in the chat as well.
Yeah, and seriously, I was talking about the first 5 minutes. This is not telling you what happens.
Yeah, no, you're right, of course, Randy. But as you kind of hinted, there's not really much given away, you know, by talking about the ending. Most folks know the ending even just from looking at the trailer or looking at the advertisements for it. I really liked the irony, even in the, you know, the ad that you showed, Randy, when you started your first slide there. It said based on truly possible events. I laughed the first time I heard that. Mm-hmm. And there's also the one moment, maybe that, well, okay, again, I won't give anything away. It was in the first 5 minutes, but that's all right. I won't say. Go ahead, keep talking about it.
Thank you, Peter.
Does anybody have anything else?
Oh, the name of the novel about Gauss.
Oh, yes. That was Jim, wasn't it?
Yes, it's called To Measure the Earth, or Measuring the Earth. I'll get it out before the end here, and it's actually a comparison between Gauss and Alexander von Humboldt, and essentially how Gauss didn't even want to leave his house most of the time, and here was Humboldt, who couldn't pass a mountain without trying to climb it.
I tried to read that book in German and was wow, it was a complicated book.
I did notice it was translated, and it's funny. It's actually very humorous all the way through.
Great. Thank you. We'll get that posted. So Dave, shall we cover your items?
Sure.
I'll just get the screen share starting, and maybe I'll start the thing the one you sent me last first. How about that?
Yeah.
While we're on the topic of whiteboards.
This is a cartoon I saw on Facebook today, which I thought was very funny.
So we can see if we can calculate that. Okay, let's end that one, and we'll see if I can. I'm going to try the items from Edmonton today from in a web browser. So we'll see. I think that's the first one.
Yeah. So this is a picture that Arnold Rivera posted. It's actually taken from Namibia by a fellow by the name of Michael Jager on December the 21st, and that's Comet Leonard, and you can see how amazingly fragmented that tail appears. Just thought it was a really good photo of the comet, which segues into the second item, which we have a link for, but I won't bore you with the link. I'll do a Coles Notes description of it. Over Christmas, Alistair Lang and Russ Sampson, and a few others in Edmonton, were talking about Comet Leonard and why in many photos, it and other comets like it were green in the coma, but there was no green in either the dust or ion tails. And apparently this has been a very long time mystery. Mary Paulson then came across an article with a link to a publication that explained the reason. The mechanism has now been proven through laboratory tests by a group in the University of New South Wales in Australia. They tested a possible explanation from 1930 that had suggested the green color comes from sunlight destroying diatomic carbon atoms, dicarbon or C2. Dicarbon in comets comes from complex organic matter in the comet nucleus. These materials are only found in extremely energetic and low oxygen environments like stars, comets, and the interstellar medium, because it's quite unstable. As the comet approaches and is warmed by the sun, the warming causes the breakdown of the organic matter in the comet's nucleus to produce the dicarbon. The C2 then migrates to the coma, and it's the dicarbon that provides the green color. As the comet gets even closer to the sun, high UV solar radiation breaks up the dicarbon by a process called photodissociation. This happens before the dicarbon can escape to the comet's tail. Hence the green color in the nucleus, but no green color in the tails. Now, the Australian experiment was difficult to do because C2 isn't very stable under most conditions that we get. So they required producing the unstable precursor, a vacuum chamber, lasers, a high energy reaction, and ion detection by the team. But they were able to confirm the 1930 conjecture. Now, it's interesting for us in Victoria to note that it took 90 years to prove an initial conjecture that was originally provided by an astrophysicist named Gerhard Hertzberg. So the observatory named after a guy who has another credit 90 years later for coming up with an idea.
So I did post the link to this article in the chat. Great. And
this is Warren Finley taking a picture of two bears, Ursa Major and a snow carving.
That's nice.
That would have been his work, the polar bear. Warren is quite creative with that sort of thing.
It's getting quite cold and snowy there, isn't it?
Yes, it was. I said for you.
Thank you very much. Any questions for Dave? Because if not, Alex, I think you're up next.
Okay, what's going on? How do I share the screen again?
There should be a button, or should be a button down on the bottom bar.
Yes.
The green thing. Yeah, hopefully it's green.
Um,
They're all every one of these turns up slightly differently depending whether you're on your Mac, PC, or an app.
okay.
Yeah, that started.
Okay.
we just got your browser page at the moment. So
I don't want that. Come on.
yeah, there you go. I think.
Okay, so everyone can see there's only one crane left.
Yeah.
And there's on the left side is the new building that's up. That's probably almost that's completed. You just have to do the outside and the inside. That's from the 4th floor in the lounge. I took it from the window. So that's finished. And there's the crane for the second building.
Kind of looms over the student union building, doesn't it?
Yeah. That's supposed to be the new dining hall in here with the windows, I think. Or
Yeah.
I'm not sure. That was taken in November the 16th. And this is the second building. That's the first, that's what I said, it's finished. Basically, it's finished.
Can you remind us what these buildings are for again?
That's for the residents, so students can live there. And there's one building we have a lecture hall, and I think the other building we have the dining area. And that's the crane. And that's the second building.
Oh.
Yeah. Yeah, it's doing more cement work, as you can see, with the cement pumping for the second building. And that's the first building, which is basically complete. And this is from the ground, from this side. And I think that is, yeah, that's
Yeah,
it.
this is the view if you're out pretty much outside, almost kind of looking from Bob Wright that way.
Yeah. So this is Ring Road, and this here's Elliott, and there's that new building. Okay, so we're gonna leave this, and I'm gonna close this, and then I'm gonna show you. I took some attempt of taking pictures of the sun with sunspots. And that's done point and shoot camera through the eyepiece. So you only see 3. That's a little bit zoomed in, but that wasn't that great. Now it's better. You can see the 5 sunspots. There's 1, 2, 3, and there in that corner is 4. And this big one has a small sunspot beside it. I don't know if anyone saw that. But that was my attempt in taking a picture. And the next one is, that's bad. So this one, you definitely see the 5 sunspots.
Yeah.
So Alex, this is your cell phone taking a picture?
No, camera.
Of the camera?
Just the camera through the eyepiece. The sun was very low down. As you see, it's all atmosphere up here. Okay, gonna stop sharing. Any other questions?
Yeah, that's neat to see. We're getting some sunspots back.
Alex, that's through your Dobsonian or your Newtonian? Your Newtonian?
The Newtonian, the 5-inch.
Right.
And I put the camera in front of the eyepiece. The eyepiece, it was a 25mm, and then I tamped it, and then I took pictures. That's why you see all that shimmering on the edge of the sun. Very noisy, or whatever you want to say.
Great. Well, thank you very much.
You're welcome.
Any comments, questions? Okay. If not, Chris Gainor, you're up.
Okay, well, there's been a couple of things happened since our last get together. I've been filling this out, the JWST to-do list, and a lot of it has been done, but there's still a heck of a lot to be done. And just a minute, I'm just going to do the share screen here, just a second. Okay, just a second. I wish the share screen in this thing was not so touchy. Okay. And can you see it?
Yes, it's there. Yeah.
Okay, is this better?
And it started the slideshow. Yes, that's good.
Okay. So Christmas morning, you know, of course, when we were all kids, at least if you were anything like me, you were always getting up at a ridiculously early hour on Christmas Day, you know, hoping to get at your presents a little earlier. I know. So anyway, I got up at about 4 o'clock. I suspect some people got up even earlier to see, is this all going to happen? And so at about 4:20, this was what we were treated to, the Ariane 5 heading off from Kourou on the equator in French Guiana. And it was pretty cloudy, but the weather was not bad enough to postpone the launch, like as happened at least once. There were a number of postponements in the last few days, the last one being for bad weather when it was supposed to go on Christmas Eve and it went on Christmas Day. So we had, it was basically attached to the Ariane for about half an hour after flight. And the picture at the top here shows this is the bottom end of Webb moving away from the top stage of the Ariane where this camera is. And then the other picture shows the solar panel deploying. And that was a huge relief to everybody, because if that panel didn't deploy, Christmas would have been a pretty bad day. As they say, $10 billion and how many astronomical careers, I don't even want to think about it. So that was kind of the last view from space we had of Webb. But we have had a number of views from Earth since then, and this is my favorite one. Just a very short time later, you can see Comet Leonard here, and the JWST. I think it was still attached to its stage at that point over Thailand as it was moving away. And I've seen a number of photos, usually of dots or streaks of JWST since then, but you know, the sensation I've sort of gotten in the last couple of weeks since it was launched is, you know, this thing is really moving a long distance away from us. And even though it is a very large instrument, as I've seen with my own eyes, it's the distance is becoming far more important. So this is kind of what we've been dealing with in the last little while. In fact, I made this image at the wall, my computer wallpaper, so I was instantly you know, updated, and you can see that we've kind of gone through most of the steps. You know, first you see what it looks like when it's separated from the Ariane, and then the solar panel deploying, and then the panels for the sun shield. And so first of all, they had to spread out, and then there was a short delay around New Year's, I think, where everybody in the control center decided let's take a little break, and there was a lot of work done to separate the 5 layers of the sun shield, because the telescope itself has to be at extremely low temperatures. So so that division took several days of those 5 layers, and there was a lot of things that could go wrong there, because there were a lot of little motors and things that had to move, and things had to stretch out, and you prayed that things didn't tear in the wrong place. And then after that was over with, then the secondary mirror was deployed, and of course, if that didn't work, it was going to be a bad day, but it was a good day. And then the 2 side panels in the main mirror of the 18 segments, which were folded back, they turned around late last week, and then on Saturday morning, I crawled out of bed, and they actually had some live coverage, and the second side panel moved into place and then was latched, and then there's a celebration that went on in the control room for James Webb, which is on the 2nd floor of the Space Telescope Science Institute in Baltimore. And I know, Jim could probably make his way around that building blindfolded. I've been in there a few times, and so a lot of excitement there. And most of the people there are kind of staff who have been working for several years for just this deployment sequence. So probably most of them are moving off to other things now, although there's more work to do, as we'll see in a minute. But it's just it was such an involved thing, and anybody who knew anything about it was kind of nervous for the last couple of weeks. So this was a big event. Now, James Webb is actually different from Hubble in that, except for the period of a year or two, and if you want to find out about that, you can read my book. Hubble has been controlled from the Goddard Space Flight Center, but the scientific work is done at the Space Telescope Institute. But the control center for JWST is not at Goddard, it's at the Space Telescope Science Institute. One reason for that is because when JWST gets into its final position, which it's supposed to do on the 23rd, I guess that's is that late next week, I guess. It's actually in a much more stable situation than Hubble is, because of course Hubble is orbiting the Earth every 90 minutes, and half that time it's in the shadow and half that time it's in the light, and there's all sorts of things that have to happen all the time. JWST is kind of in a bit more of a stable configuration, so I think in that sense it's a little easier to control. This is a reason why it's not at Goddard. So this is I just put this this is the website Where is Web, and this was just about 5 or 10 minutes ago. I just took a shot of this page and uploaded it, so you can see how far it is away. You know, 1.15 million kilometers from Earth, and about what is it? Nearly 30,000 kilometers to its orbit. In other words, it's 4/5 of its way to the orbit. Now, the interesting thing is the temperatures, which are still diverging. On the hot side, which is the bottom side of Webb, that's where the solar panel is, some of the antennas, things like that. And then on the cold side, where the telescope is, and it still has to get colder. So this is something that's going to be going on in the next few weeks before they can start sort of really setting up the mirrors and calibrating them, and also the instruments. The instruments also have to cool off, and I think at least one of the instruments needs has its own cooler to make it even cooler than everything else. There's a lot of work to be done. So this is just a little shot I took off of a YouTube thing that's showing, you know, we have 18 segments in the main mirror, and they all have to be adjusted to point correctly at the secondary mirror at the top. And the secondary mirror also has to be correctly positioned. So there's a lot of work to be done, because they were actually fastened down, and I think still are fastened down in their launch position. So because if they were sitting on top of their I've just forgotten the words for the little motors that put them into the right place. But anyway, actuators, that's right. That wouldn't be a good place for them to be during the launch, because it's really rocking and rolling. So they were fastened down. So they're either doing it or about to unfasten all these mirrors, and then they have to start pointing them. And it's not just sort of, oh, well, we just aim it at the same point of light. You know, I think anybody who's made their own telescope, ground the mirror, has a sense of what a dark art optics is. It's not only sort of aiming them the right way. You're talking about, you know, light waves and things like that. It gets very complicated, and there's a lot of algorithms involved. I was interested to hear that the algorithms were actually the art of developing these algorithms was actually advanced while they were dealing with the problem with Hubble's mirror, when the main mirror was ground the wrong way, and then they had to figure out how to correct things. And actually, some of that work is paying off here while they get James Webb setup. So anyway, we are the next big thing is for James Webb to get into its correct kind of little orbit around L2 on the 23rd, on or about the 23rd of January, and it's not something that has to be met at a precise moment. It's fairly approximate, we've been told, and then there's going to be a lot of work done. Getting these mirrors set up, and then getting the instruments calibrated, and they're going to be taking lots of images along the way, but they're just going to be crap, so they aren't. There's going to be no suggestion of let's show the folks this blurry star or this one with 18 stars because the mirrors are pointing all sorts of different directions. And it's going to take months. I was watching one of the briefings, and somebody said, well, you said it's going to be June until we start getting, some serious images coming down from Webb, and whoever asked the question kind of thought like me, is in that they thought, well, they're saying June, but actually, if things work out, they might be able to slip one in May or something like that. And actually, they said they have things. The timelines on that are so fine that right now they think that they might be able to get the pictures done or the first images done a day or two earlier. So there's not much wriggle room on that. And now they haven't said it's going to be June 16th or I don't know. It's sometime in June. They apparently have decided that when they do start releasing some images, there will be some fairly interesting objects. I think they learned their lesson about that from Hubble, because there was kind of a big argument, and this is like 30 years ago when Hubble was first launched, as to whether they should go for some images that would have some appeal to the public. And there was a number of scientists with the best of intentions who didn't think that was a good idea. What happened, of course, is that when the mirror was screwed up, they changed their mind over that time, during the 3 years until the mirror was repaired. And so we ought to be seeing some interesting images from JWST. I was having some chats with some people. Of course, anything of, especially of faint fuzzies, maybe not necessarily something like the moon, but any faint fuzzies that you see an image out of a telescope, or even what you see when you put your beady eye up to that eyepiece is not necessarily what you would be seeing if you were just standing off that galaxy in the Starship Enterprise or something like that. And some of the astrophotographers, of course, are aware of the Hubble palette, and as kind of a device to create images from Hubble. And I'll be interested to see what the equivalent of the Hubble palette is for JWST, because of course it's operating mainly in the infrared. But anyway, I think I've probably said enough. If you have any questions.
Chris?
Yeah.
So this hexagonal mirror reminds me of the Keck Observatory, right? Like the Keck telescope. So is that it's basically, I know the Keck corrects for atmospheric disturbance and this doesn't, but it's the same sort of thing in pointing the mirrors, is it not? Or is it?
That's right. It's it doesn't have to be that shape particularly, but it's just, kind of, when you're putting it together, that just a shape that kind of makes sense, from the physical point of view more than anything else. So, if we came back in 100 years or something like that, and they're launching the whatever the space telescope is of that day, and it has 1,800 segments, it might look more like a circle, a circle. But anyway, this is what we've got right now.
Peter, did you have a question?
Yeah, Chris, I wondered if if of all the points of failure that we keep talking about, if one of those mirror segments has a failure in one of its actuators, can it be set in such a way so that it doesn't ruin the image?
That's a good question. I've actually thought of that myself, but I haven't seen the question posed to the people concerned, just watching the briefing once on Saturday, they seem to be pretty confident. I forget how many at the time of launch there was like some hundreds of single point failures that could screw things up.
I heard
really
344.
badly. And they said as of Saturday, there are now 49 single point failures that they're concerned about. But those are all things that could happen, they could happen today, or they could happen on the last day of operations. And they sort of said, these are the types of things you worry about in any spacecraft of this type. So, I wonder if there's a bit of a backup capability in those actuators, but I'm not totally sure about that. Incidentally, one point I wanted to make is they've been talking about this thing operating for about 5 or 10 years. And because it's so far away, 4 times as far away as the moon, and requires fuel to change directions, which is limited supply. They were talking about that. But the Ariane did such a great job, and the first course corrections required so little fuel that they're now talking about 20 years of operations for JWST, which is a great thing. And of course, that's a huge feather in the cap for the folks who built and launched that Ariane rocket.
Les, do you have a question?
Yes, Chris, you were just referring to the numerous points of failure. I understand there were 168 latches, for example, that all had to release, and numerous other components. Somebody, or maybe several of the aerospace engineers, must have done a calculation of the probability of successfully completing all of these operations. And I'm sure they wouldn't release that range of numbers ahead of the mission. But are you watching to see whether somebody releases those kinds of calculations now that they've more or less succeeded, or they're coming close to sucking? Because it would be very interesting to see what the probability of success actually was thought to be.
Yeah, I'll be keeping my eye out. Now this actually reminds me of a question I've been asked a few times in the last couple of weeks, and I wrote about it in my most recent blog. But a few people said, so you've written a book about Hubble, are you going to write a book about James Webb? And I'm not going to, at least not in the immediate future, because there's a very good friend of mine named Robert Smith, who was my faculty advisor when I was getting my PhD. And he wrote a book called The Space Telescope, which is the book that tells you how Hubble was built. And that book came out, 30 years ago. So when I first encountered Robert Smith, he was not only doing his academic work with people like me, but he was also collecting information for his book about how JWST was built. And so now that the thing has been launched, I assume he's going to finish off that book and get it out. And it will be an interesting story, because the JWST's journey to the launch pad was a very difficult one with many twists and turns. As you might have guessed from all the postponements, this was supposed to happen years ago at far less cost. Now it's cost about $10 billion. And he might have some idea what the odds are of this thing failing.
Yeah. Gary, you have a question.
Yeah, comment to David Payne's question about the mirrors. The actuators on the main mirrors here in JWST and also in Chit are used only to get the figure of the main mirror. Any atmospheric correction is done with separate mirrors in the Keck telescope. And of course, you don't need to do that with JWST. Dr. Hessen knows all about this far better than I do. I have a question for Chris. Chris, you mentioned the accuracy of the Ariane spacecraft. What actually goes into making a really accurate deployment, flight like this versus something not being so accurate? Like, I was kind of surprised to hear that this was done so well. Well, you would think that they're always done so well. Have you any idea what the factors are that affect the accuracy of the space flight?
Well, I guess it's an Ariane 5, which has it has a couple of let's see if I can just sort of nip back to the launch photo there. So you can see along the side there, it has a couple of these Roman candle type things, like the solid rocket motors, similar to what they had on the shuttle. I think those are made in Italy. And then the central stage is quite large. And then there's the second stage. Now I think those main stages, just sort of kind of have to do a lot of brute work, and then the second stage operates a bit more finely than that. It involves basically pointing it the right way with great precision, and also the thrust starting and beginning at precise times. More than anything. You could have problems like, if they didn't load enough fuel in it or something like that, or didn't know exactly how much fuel is in it, so that you didn't know the right weight of the thing, which you need to correctly get it into its course, and know how long it's supposed to fire and things like that. And I think there's a couple of small rocket motors in Webb that did the first couple of mid-course corrections afterwards, but they didn't have too much work to do. Now, the thing about the Ariane, what is it? They've launched about, I think this was 564, if my memory serves me right, which means they've launched 64 of these rockets, and these are amongst the biggest rockets available today. The Ariane 5, and it's got a fabulous record. Although the very first one went up about a mile and then started doing cartwheels because they put the wrong software in it. They had the software for an Ariane 4 in it, thinking that they didn't need to update it, or somebody thought that, and so it was a complete fiasco. And basically, it has an almost spotless record since then. I think there was a couple of situations where the upper stage didn't quite work the way they wanted to, fortunately, the satellites were able to get into the right orbit, but they had to use up a lot of the fuel they had on board for other purposes while doing that. So they were extra careful with this launch about issues like that, making sure they got the right amount of oomph out of every stage. And there was a lot of angst before this particular launch about the shroud around that protects Webb during its launch. They had a flight a year or two ago where the shroud didn't separate the way they expected to, and if it goes at the wrong time, you're carrying all that extra weight, because the shroud has a lot of extra weight, and they want to drop it off as soon as they can, so that you're only carrying what you have to once you get above the atmosphere. And so that can affect things if it doesn't go off at the right time, or it doesn't go off the right way. And we've had incidents where things get hit when these things separate. So there's actually a lot of work done, and the previous two flights of the Ariane had extra instrumentation on board to make sure that the shrouds for those flights separated correctly, and they did in those cases, and then they got the green light to go with this one, and so it all worked out. And I think there's only one or two Ariane 5 launches left in the series, and then they're going to retire the Ariane 5 and go to the Ariane 6, which actually is looks quite similar to the Ariane 5, but I think is a bit more powerful.
Thanks.
And Ken, you have a question?
Yes, a side note, the compressor I thought was quite interesting on Webb there. They couldn't have any moving parts on it, so I believe it's run off of acoustics, which is pretty interesting. For $110 million. But my question to you, Chris, is I heard that the Webb will be receiving about 1 photon a second. I would imagine that would be from the Big Bang. Is that correct? And if so, what sort of subs do you have on that?
No, actually, that might be something that somebody like Jim could answer a lot better than me. You know, there's sort of I'll just make one comment that there's kind of it's kind of a dynamic situation out there, because you are so far away. You know, you are subject to the solar wind, for example. you know, in addition to whatever light happens to be coming from various places. So, so that's, you know, sometimes people will ask, well, why can't it just go there and sit there? Well, it can't because of things like that. But as for the photons, yeah.
Actually, I watched the same video, you guys, and what they were talking about right then, Ken, was looking back at the very, very first galaxies. They're so faint, only 1 photon a second actually gets to us. Other targets, of course, it's not going to be that way. They're just talking about the really, 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 really faint ones.
Yeah, that's what I assume, but how do you manage that?
What do you mean manage?
Well, do you mean image that?
Yes, yes.
That's a good question. I can't answer that one.
Okay.
Lots of seconds. Lots of seconds, I guess.
Or years.
And there's 2 questions in the chat. So from Logan, how is this pointed? How does it, how do they control what it's looking at?
Well, they, that's, I actually could probably use a bit more education on that, but, you know, Hubble was using, you know, what is it, momentum wheels and gyroscopes and things like this. Here they have to use the thrusters a little bit to aim it, and I think there's sort of limits to its movement because they don't want, you know, the side with the telescope on it has to be in darkness all the time to maintain that low temperature. So I imagine there's some pretty sharp limitations on what it can image and when it can image them, so that the telescope is always in the darkness and the coolness.
We had a speaker that said most of the fuel is actually used to point the telescope, and only a small portion is used to maintain the orbit.
Yeah, I think that's right. But yeah, the exact constraints, yeah, I haven't gotten to that part of the manual yet.
Very good. Yeah, and then related to, yeah, and then I think, is it Dwayne has posted, I guess it's something that maybe explains some of that. So there's a link in there as well. And some good information is shared in the chat tonight, so.
Yes, and of course, the important thing for us to remember is that as Canadian taxpayers, we have some skin in the game, and one of the instruments and some of the other equipment on the telescope, navigational, I think, and and you know, a lot of work was, you know, some of the people who made the flight up to now possible, or you know, some of our friends up on the Observatory Hill there, and some of them already have time on the telescope once they can, once that's open for use. So this is a bit more personal to us, I think, than Hubble was.
Yeah, it's well, it's a project a long time in the making, and it's exciting to see it actually now really start to happen. Thanks for keeping us up to date. Are there any more questions or any further comments?
I just have one, Chris. For Chris, sorry, as Chris, will the data be at the data center for this one, like Hubble is?
You know, I haven't asked that question, but I would be shocked if that wasn't the case.
It is the case. It's going to be
Yeah.
posted on Observatory Hill.
Yeah.
Thank
Because,
you.
I mean, there's a couple of reasons for that. It's good to have that data in more than one spot. And one of the stories of Hubble, which I only was able to touch on briefly, very briefly in my book, but I may actually do some more research on this going forward. Is the folks who developed the data center up on the hill, their work was really important in creating that Hubble archive. You know, when Hubble was launched, they didn't really have much of an idea about how they were going to deal with all that data, and they got a lot of help from the folks at the Canadian Astronomy Data Center. And that, you know, that's why they are one of the 3 depositories in the world. You know, the one at the Space Telescope Institute, the ESA in Europe, and then right here in Victoria. And you know, that was back in the days when Hubble or Canada, when, you know, that's with the telescope Hubble, where Canada actually wasn't officially a partner, but that was our big contribution, aside from the individual contributions of you know, a lot of the scientists up on the hill and just doing their research. So,
Well, thanks again for all the information and giving us an update. I'm sure we'll be checking in with you as the days pass toward day 29 there, I guess it is, when it should get to where it's supposed to be.
that's right, January 23rd.
Yeah, very good. So I think if that's it on James Webb for the moment. Reg, there was a snowy visit to the VCO, I believe.
Yes, Chris. Happy New Year, everyone. What a great way to kick off the new year with this stellar Astro Cafe tonight. A lot of great presentations. Mine may not be so powerful, but I just want to say that on December 25th in the morning, I was in a hotel in Vancouver, and I set my alarm at 4:10 in the morning to get up to watch the launch. And my wife did not share my level of enthusiasm with that. I'll say that, and I'll leave it there. But I did have to try and explain it to her why I was so excited, and I don't think she bought my argument. At any rate, I think that they've done a wonderful job of keeping us informed since the launch on all of the websites, and I've been tuning in from time to time, and really it's been kind of like candy. But the James Webb Space Telescope is not the only telescope that's being commissioned. And the Victoria Center Tech Committee has been working on the telescopes up at the VCO for a while now. And the one thing I can say is that we have become experts in the single point of failure, because we've had quite a few little problems creep up, and yesterday was no exception. So I'm going to attempt to share the screen here, and let's see, try that.
Does that relate to my comment about optics being a dark art by any chance?
Now look at here, I'm already lost. I'll see. Can anybody see anything here? This is a picture I want to show. Can you see something?
I don't think the sharing's been confirmed. So when you click share screen, then you have to choose what you're sharing. Has that been done?
Oh, you don't see anything?
No, I just see the gallery of people so far.
Well, okay, maybe I'm lost. It's the first time I've used this computer on this system. Bear
So
with
click
me,
share
please.
screen and then confirm it's the screen you want to share. I think it's what it. Yeah, should say something like screen.
Share screen.
And then you have to choose what to share.
Yeah. I'll try Safari.
Okay, see if that works.
Sorry, folks. I tried desktop one, and I shared something.
Yeah, it didn't come up for us yet.
Well, you know what? I probably have to change my preferences to share the screen. So I'm going to scrap it. I won't show it. Let's just see. Well, I have to allow Zoom.
Ah, there you go. Privacy settings.
Yeah, I'm just going to share. They're going to record my password here. And it says now quick and reopen. So I have to leave the meeting. Guys, it's been a great start talking about singles point of failures here. I'll see you later. I'll try and come back, Chris.
Okay, thanks. Okay, while we're waiting to see if Reg can reconnect with us and everything, one of the ongoing sagas was the shipping of things in our direction from the national office. And I was just going to check in with Lori. I take it we haven't gotten calendars yet, I guess. You're muted still.
No, I keep looking a couple of times a day. I go outside to see it, and if a truck stops outside my house, I go racing out to see if there's somebody that will leave something with us. No, we still don't have any calendars. And I know that there was an update again this morning for the bulletin for anybody. There's nothing we can do. It could very well be sitting in Saskatoon or Vancouver or somewhere in even a Victoria a Victoria warehouse, and it just hasn't gotten to us yet. So we will continue. I will put another little note out to Reem Khalifa at National, just to let her know that we haven't got it yet, so that she can keep track of that. And we just hope. Please don't give up hope, please.
And I was going to say,
has anybody gotten a handbook?
Yes,
Oh,
I
yes.
had
Has
my
anybody
handbook before Christmas.
Yeah.
Yeah, some people did. I haven't
Yeah.
yet.
No.
Yeah, I got
Okay,
mine
my-
between Christmas and
British
Easter.
Columbia addresses, I guess, in that breakdown where they said where they hadn't been sent. And unfortunately, of course, with the chaos of getting our connections to the rest of the country seem to have been a little bit disrupted. And I guess that's also added to the problem. And I was going to say,
there was that
Bill,
article in the Times Colonist a couple of days ago about how Canada Post is all screwed up, and so, and there's other things too. The only copies of my Hubble book that I've got were the two I got by FedEx, and I was supposed to get some more, which I was hoping to share with a couple of people, and not yet.
Get used to the disruptions between the COVID absenteeism and other problems. It's going to pile up and accumulate over the next couple of months. So,
and I was going to say thanks to Bill for sharing that on the RASC Vic list, the information, because if you're on that list, you saw essentially a summary of what they said in today's bulletin last week. So that was it was good to see what another reason to be on that list. Reg, I see you have returned.
Yeah, is it okay if I try and share the screen again?
Please try again.
And I apologize if this is a train wreck. Let's see.
No such thing. There we go.
You see something now?
Oh, that's not a train wreck.
we see a kid.
That's no
Okay.
train wreck at all.
Let me see here. Okay. As you may know, that we have been working at getting a camera and filter wheel robustly attached to the back of our 12.5-inch OGS telescope. And yesterday, David Lee and I went up there, and we've had a kind of an issue here with getting the right connectors. We got a thing from Precise Parts in Florida to make a special customized thing to attach a helical focuser to the backplane of the telescope. We have a Borg helical focuser that was donated by Bruno. Then we got this from a place called Hutech in Los Angeles. This little gadget here came from Gina Astro in Los Angeles. This thing here came from Germany some time ago. And we have the odd spacer here and the odd spacer there. So it was something that took some time for all of the parts to get together. So yesterday we were really keen. We went up to the hill to put it all together, and we got everything set up. So basically, this thing here is called a field flattener, and it takes distortions out of the Ritchie-Craichan telescope image. This device here is the Celestron off-axis guider, and then we have the QHY filter wheel that has place for 7 filters and electronically switches the various filters in. And here we have a state-of-the-art monochrome camera called the QHY 600PH. And this camera takes 60 megabyte images in each. It's a monochromatic camera. It cools things down to about minus 40 degrees below the ambient temperature. And it is kind of state-of-the-art, a very low signal to noise ratio, a very low readout noise and everything like that. And kind of a massive amount of data is going to be captured with this thing. And so we've been working away at that, upgrading our computer with USB 3 lines. And a huge shout out here to David Lee, who's been doing a lot of the software work on the computer and configuring that and helping us out in every step of the way. And yesterday we fed a nice USB 3 cable through some conduit. So we have an extra cable up there because the data flow from this thing is so great that we don't want to mess that up. Each of the images is 120 megabytes. And so if you've got red, green, blue filters, you can see that the size of the image data is fairly substantial. So that's an important configuration. So last night we got up there at 4 in the afternoon, and the moon, as Randy and everyone else attest, was beautiful, sitting up there at 41, about 45 degrees above the horizon. And we were just absolutely pumped that we were going to be able to turn on the telescope up there and focus on the bright moon while we weren't totally in the dark, so we could get everything working. And then David reported that the controller for the computer board had failed, and we could not fire up the software to control the telescope. So that's our single point of a failure at that time. Fortunately, Dan Posey has generously offered to give us his older video card for his other computer, and so we should be back up and running when we next get our system up and running for the next weather event. And then we'll take it for there and see what happens. But based on numerous episodes we've had already, we've been kind of conditioned, and this may not be the last single point of failure that we have. So we'll see. But Our goal is to try and get our first picture before the James West Space Telescope does in June. So I'm sticking with that. And I'll see if I can switch a picture here. And this is the parking lot of the VCO yesterday. It was 6 inches of snow on the parking lot and pretty icy road there. So they plowed the roads up. They're in great conditions up to the 48-inch in the Plaskett. So we parked up there and walked down. But it is a pretty slippery slope to go down. So would probably be a while before we get back up there. So with that, Chris, I'm going to stop the share and turn it back to you.
Great, thanks, Reg. Does anybody have any questions for Reg? Or? Very good. Okay,
that's a really long optical train. There's no flex in it.
It's pretty solid. Actually,
it?
Reg and I challenged each other in terms of the rigidity of the train. And I even asked him how many turns he had on each adapter. So we went through that pretty carefully. So it's pretty solid.
The answer was 4.5 turns for most of those threaded things. So it's pretty robust. We put a lot of thought into it. Our initial configuration was held by 2 thumb screws. And that was not a robust situation. And so once we learned the vulnerabilities of that, we went back to the drawing board and we started ordering parts from various agencies. So it's been a long journey.
Oh, Reg, we also balanced the tubes too, balanced them out.
Yeah, we've balanced the telescope out. The weight didn't add very much to the right ascension, but it because all the weight is on the back of it, it made a big impact on the declination axis. So the easiest way to balance the scope was to loosen off the Takahashi refractor and shift it forward a bit, and we got her all in condition now. So that's all done.
Yeah, dual duty. It makes a really good balance weight as well.
Yeah.
Do we have, with that length out the back of the tube, is there any chance that it could hit something in slewing around?
It could hit rascals.
Yeah, that's what I was wondering about. Yeah, so we'll have to be a little careful with that.
Yeah,
I guess, because that probably would not be a good idea to hit something with that.
Yeah, you do have to worry about orientation in the VCO. It's we've pretty well stretched our limits in terms of the size of equipment, so you do have to be careful. But I think it's pretty well arranged. I think once somebody's in there, you get to know which things to avoid, like the counterweights and the optical train as well.
Yeah, yeah. Just noticing that. Yeah, that seems quite. Bigger than it was, longer than it was. Yeah.
Diane Bell used to really stick a lot of glow tape on the stuff at the extremes of her telescope. Maybe we could do something like that too, so you don't bump into things.
Mm-hmm. Yeah, that might be worth doing. Great. Well, I think that was what I had on my list. Before we went, who is it? Well, there's been so much in the chat tonight. There were some photos taken by Mike Nash, and he posted a link to those. I think that was one of those that Randy showed in his presentation. He was doing a moon series last night. So I think those were, yeah, that was last night. So, and lots of information about James Webb. So that's great. And thank you for everybody who's posted bits on that. So we'll maybe try and capture some of that, I guess, to include with the information that we'll post on the web. So next week we should have a regular cafe, and then the following week, if I'm not mistaken, David, we have a speaker. Is that correct? On the 24th?
I believe so. I'm gonna have to check into that.
Yeah,
but I think we're pretty well scheduled outwards, at least a month or so. So
yeah,
there's definitely somebody there.
Yeah.
We do have a speaker. It's Tanya Harrison.
Oh, right, of
speaking.
course. The Mars gal.
Oh, sorry, you arranged that, Margie. I was thinking that was the one that David had told me about. Oh, okay,
Right.
Good.
And Chris, on the 22nd for the star party for the FDAO, there is Charles Ennis, who is our first vice president for the RASC, for the National RASC, is giving a presentation. He just lives across the pond here in Seychelles. So he's just from the Sunshine Coast, and he has done a whole bunch of work on a world asterisms project. And he is going to be talking about all the work that he's been doing on that. It should be just fascinating to see what he has produced in terms of the work put in that is a global and cultural set of information, like almost 5,000 that he's put together, like just unbelievable. So I hope everybody can come and have a look at that. It's going to be really fun. So
what's the date?
January 22nd. It's a Saturday night. It'll be from 7 to just about 9:15, 9:30, something like that.
Yeah. So not the next Saturday, the Saturday.
Not, you're right. That's right. It'll be in the following Saturday. I just wanted to, if people wanted to put anything on their calendars, just to heads up for the 22nd.
Yeah, please remind us next week. That will
yes, we will. I will. I'll get a little presentation ready.
Yeah, that would be good. Yeah. So, and again, thanks for everybody sharing so much interesting stuff this evening. Just to note too that those who are on council, we're still on for the council meeting tomorrow night. Correct, Randy? Randy is nodding. Excellent. So we'll see everybody who's on council at that. We also have the AGM coming up, and so just a reminder, if you're interested in joining council, please discuss with one of the current members, particularly Reg is your kind of contact person as past president, as he'll be running the election that we will need with so many people running for all these roles this year. But no, we desperately need some people to, there are some positions that need filling. So if you are at all interested, please do get in touch. Did I forget anything? I usually manage to forget something.
Well, I
But
can't
anyway,
make it to the council meeting tomorrow. Just want to mention that.
Say again, Alex?
I can't make it for the council meeting tomorrow.
So if you do have anything to report, you could send it via me or to Randy directly. That would be great.
I showed you the pictures already, so.
There we go. Construction continues at UVic, so there we are.
And yesterday, someone was in the library and picked up 3 books.
Wow. Very good.
First customer.
Yeah. Excellent. Yeah. So, well, again, thank you everybody for attending this evening, and it's good to see this is one of our greatest attended meetings for quite a while, except the ones where we have speakers. So it's good to see everybody turn out tonight, and hope everybody had a good holiday break, and obviously did, because you've come back to Astro Cafe, and we seem to have a lot of interesting things going on this evening. So if there isn't anything further, we'll see some people tomorrow evening, and if not, we'll see people back on Monday, the 17th. So thank you again.
Good night.